Good morning, everybody. My name is Dr. Bayo. I'm going to be the recitation teacher for this class. If you're continuing on to OChem 2, I will be the lecture and recitation teacher for that class. So you guys may get either a small dose of me or a large dose of me, depending on what your plans are for this summer. I think most of what's in the syllabus is going to remain. The only real change is I'm going to do 3 quizzes a week and drop one of them. So I'll take your 2 best quizzes. I think in the syllabus it says that there are just 2 quizzes per week. So it gives you guys a little bit of leeway in case something goes wrong in one of those. Today, was there anything else? I'm sure it'll come to me. Anyways, today I'm going to kind of do a little bit of review of some stuff you guys talked about in class, give you guys a little bit of time to work on some problems. If you guys have questions, please feel free to speak up. For office hours, I think I'm mostly going to stack them on Thursday nights because you have your exams on Friday. I'll send you guys a message probably today giving you the exact times, but I think that's probably what will be the most beneficial, seeing as you guys already have so much time in class, as well as this recitation right after it. If there's any questions right off the bat, feel free to chime in. If not, I'm just going to kind of review some functional groups and maybe talk a little bit slower through them, and hopefully that'll help you guys out with what you guys talked about today. So I am going to switch over to my whiteboard, which hopefully all of you guys can see. And hopefully you guys can hear me. Yeah? Any responses in the chat? Or out loud?
Yeah, we can hear you.
Okay, great. So let's talk about some common functional groups. Chris gave you guys a little bit of a table. That's the wrong thing. Where did I go? Okay, now let's see. I want to get out of full screen here. So most common functional group is literally just carbon. It's called an alkane. There's a bunch of different ways that we can draw alkanes. In 109, 110, you guys probably did a lot of where you're drawing out the full structure. So something like, I'm going to draw this 3 different ways. One of these 2 here. In OChem, we like to simplify this. So we are going to draw this as just these 2 lines here. And for carbons especially, because we know that carbon always makes 4 bonds, we're just going to assume that everything else is a hydrogen. So this carbon here currently has 1 bond, which means that it needs, if we were thinking about trying to break it down, it would have 3 more bonds to it, to hydrogens. This one in the middle has these 2 bonds already, which means it needs 2 more. And then one on the end here only has 1 bond. So hopefully this is a little bit of a review for you guys. That should not be too complicated. As we look at some more structures, so I'm going to get rid of most of this and redraw just our alkane up here. An alkene we're going to change the suffix at the end. So we had ane over here for all single bonds. So when we add a double bond, we're going to use this suffix ene. And when we start doing namings, the double bond things are going to end with ene. So it's going to be continued there. So this would be something like this here, where we have a single double bond. And I could also draw this out. Fully, and it would look something like this here. If we take a look at our structure, again, so we always have this concept that carbon makes 4 bonds. So we treat a double bond as if it is 2 bonds. So this carbon on the end here, I'm gonna highlight it in blue. It has 2 bonds already from the double bond, which means it would have 2 more hydrogens here. We don't always draw them out because they're implied, but I'm going to go through them with you guys just so you guys get a sense of it. This next one in the middle, you can think of that as already having 3 bonds. So we just have 1 hydrogen. The one on the end only has 1 bond. And that's where we get this full bond line structure. So I'm going to erase some of this. Just leave our skeleton here. The last functional group in this like little trio is going to be an alkyne. Which is a triple bond. Our suffix is YNE. Some people like to memorize it. It goes in alphabetical order. So A, E, Y, single bond, double bond, triple bond. This is going to look a little bit weird because this is going to be a linear chain. So it's a 180-degree bond. We have a carbon, a CH3 here, another carbon with no hydrogens on it, and 3 bonds to a CH. This one on the end, what's be hard to draw, has 1, 2, 3 bonds to it already. So it would just have 1 more space open that we could fill in with the hydrogen. This one in the middle has 1, 2, 3, 4 bonds already, and then the one on the end has 3 bonds here. Okay. So let's draw out a structure. I have a complete delete button, don't know why I didn't use that, okay. Generally speaking, we don't think of an alkane as really a functional group, it's just kind of there. So I'm gonna have you guys, I'm gonna give you like 2 or 3 minutes to just label the functional groups on each of these positions that's in red. And then I'm going to draw some arrows in green. And I want you to label the number of hydrogens at those positions. So it's the number of hydrogens that we're not drawing in. So I'll give you guys, I don't know, till let's say the 27, and then we'll go through them together. I'm gonna draw a little example down here, what I'm talking about. All right, so what functional groups are alkenes? And feel free to just shout it out.
1 and 2.
Right, yeah, so 1 and 2 both have double bonds. So we can easily recognize those as alkenes. Which one is an alkyne? Obviously, kind of by process of elimination, we could say it's number 3. So this is a really basic example of this. Let's take a look at number of hydrogens. So how many hydrogens do we have on number 1?
1.
Right, so we currently have 1, 2, 3 bonds, which means we need 1 more. Number 2.
2.
And number 3.
0.
Right, so this was what, 1, 2, running off the page, and 0 here. Okay, any questions on this? No, great, okay. Let's talk a little bit about aromatic rings, which there seemed to be some kind of discussion about in the class. So for the sake of what you guys have learned, this will probably be the only aromatic ring you really use. Because you guys don't actually know how to identify aromatic rings at this point, the one that you guys are basically to see is, this is a benzene ring. The one thing to note is that people often get confused. So these double bonds here are important to actually this being benzene. So this is different from just this without those double bonds there. And you guys will learn about that more later on, but just as something as kind of a heads up, if you see a ring, it doesn't necessarily make it aromatic. You actually have to have these 3 double bonds that are inside of it.
Does the position of the double bonds matter? Like if you shifted them all over one, would it change it?
No, and later in the class we'll talk about it. They're actually not really here versus here. They're actually kind of in all the positions, but I don't want to complicate you guys with that until you guys start talking about that concept yet. So, but for benzene rings, as long as there's 3 double bonds somewhere in it, it's going to be an aromatic ring.
Thank you.
Yep. Okay, so let's take a look at some. So halides are pretty straightforward. If you have something in, it's the second to last row on the periodic table. You have fluorine, chlorine, bromine, iodine here. These are all your halides. So if these are anywhere on a molecule, this would be considered a halide group here. As your functional group for this, they're pretty straightforward because they're in this last row. They all can only make 1 bond. It's going to have 3 sets of lone pairs here. So the only thing it can do is be directly bonded to your molecule, which is going to be nice. Compared to things like oxygen, which can make different types of bonds, this can literally only be attached to it. Okay, let's talk about oxygen. Was there any questions on halides? No? Good, okay.
Was that a functional group or?
Yeah, it's a functional group. If you go to like the, on Canvas for the actual class, Chris has something called Common Functional Groups _McCune. So this would be number 5 on his list. And I'm kind of just gonna go down the list of these for the most part today until I get to a point that's maybe a little bit more complicated than what you guys I think will actually see. Okay, so oxygen can do a large number of things, and the reason for that is typically we think of it as being drawn like this, where we have two different bonding electrons. So it's going to make two bonds versus carbon, which can make four bonds. Nitrogen, I probably should have drawn in the middle, is going to make three. And then those halides that we just talked about, they only have one electron that's by itself, so they're only going to make one bond here. So because now they're moving on to something that can make two bonds, we're going to get different functional groups. And the first set of these functional groups are based around having single bonds to oxygen. And there's really two different ones. The first one is going to be an alcohol. And an alcohol is just where you have your oxygen bonded to a hydrogen. Our other option being an ether. And this is where your oxygen is bonded to another carbon. So you have one bond to carbon, one bond to an H here, versus over here, you're just gonna have two bonds to carbon. And I'm gonna say single bonds. Okay, so I'm gonna give you guys another structure and have you guys write out some functional groups. Okay, so I'll give you guys till 37, and then we will go through this and then keep going on. So it'll take about 2 minutes to go through this one. All right, what did you guys get for number 1?
Alkyne.
Alkyne.
Right, alkyne. So we have a triple bond here, which means we have our YNE suffix. Number 2,
Benzene ring.
right, your benzene ring, aromatic ring, whatever you want to call it. I'm gonna run out of space. Benzene and aromatic are kind of like square quadrilateral. Benzene is an aromatic ring, but not all aromatic rings are benzene. But for the most part, you guys can use them interchangeable. Number 3,
Alcohol.
Alcohol.
I forgot to put an ether on here. Oh, well. Number 4,
Alkene.
and number 5.
Alkyl halide.
Okay. Was there any questions on these? Okay, I'm gonna skip epoxides. You guys may talk about them in class. I'm not sure if you will or not. And I'm gonna move down. Actually, I'm gonna skip down to 17. We're gonna keep going with oxygen, and then we'll go back and do some more nitrogen ones. So we talked about alcohols and ethers here. Oh, sorry, my handwriting is bad. I'm not used to writing on this. And these are both single bonds. Because oxygen can make 2 bonds, it can also make 2 bonds to the same carbon. Which is going to look something like this. So it's a double bond with one side being an oxygen, the other side being a carbon here. This particular configuration where you have carbons on either side of this is going to be referred to as a ketone. If we replace one of these 2 sides here with a hydrogen, the other side still being carbon here, this is referred to as an aldehyde. We have a couple of different options. So we can also add an oxygen there in 2 different ways. So if we have just an OH, this is referred to as a carboxylic acid. And I'm gonna run out of room down here, but I'm gonna see if I can write it. If we kind of combined the carboxylic acid and the ether here, so we have this oxygen with carbon bonds off of it, this is referred to as an ester. There's also something called an amide, which I'll talk about in a minute when we start talking about nitrogens. Okay, are there any questions about these double bonded functional groups? Great, I'm gonna draw up a molecule that uses a couple of them, and I'll have you guys do some labeling. Okay, so go through and label. I'm going to give you arrows to them. I'm going to give you guys a little bit more time on this one as we're starting to get more complicated. So let's take about 4 minutes to go through this one and then we'll talk through it together. All right, so what do we have for number 1?
Aldehyde.
Yep. Number 2?
Ether.
Right, so this is something that, it is either, tends to trip people up, is that the location of your oxygen relative to your carbonyl is going to be very important. So for this example, I'm just going to draw it with the carbon there. This would be an ether, but this would be an ester, because these two are like directly attached to each other versus having this one full carbon in the middle is actually going to separate your functional groups. So it's something to watch out for as we go through these. What about number 3?
Ketone.
Ketone, right. And then 4?
Alcohol.
Alcohol.
Right, and this is the same concept. Where the difference between 3 and 4 and 6 here, so what is 6?
Carbon.
Right, and then 5, might as well just round it out.
Esther.
Oh God, my handwriting's getting worse as I write faster. Okay, so for 3 and 4, there's this space in between them, which is differentiating our functional groups by this H2 here, versus on number 6, because they're both attached to that carbonyl position. This is just one functional group. Does that make sense to you guys? And it'll make a little more sense as you guys start to talk about things like resonance and stuff like that. But essentially they have to be like directly attached, or else they're just two things on their own. Okay, I'm going to take it from the lack of response that you guys get that. So I'm going to talk about some nitrogen functional groups. There's really only, well, let's see, does he actually separate them? He gives you a couple of different ones. I'm going to go through the ones that I think you guys will see the most. So the simplest one is an amine. So if you think about nitrogen, it's got one lone pair, so it can make 3 bonds. Sometimes it makes 4, but that's a different conversation. So the simplest version of it is just with hydrogens on it. This is actually referred to as a primary amine, which you guys will talk about a little bit more later, what the difference is between primary, secondary, and tertiary. It's a pretty simple concept though. I mean, you have one bond that's coming from carbon and that makes it primary. So a secondary amine is kind of like an ether. You have 2 different bonds, both of which are attached, both 2 bonds to carbon on your nitrogen. Our third option, right over here, would be this tertiary amine. And that's where you have 3 bonds to carbon attached to your amine. So primary, secondary, and tertiary are sayings you guys are going to hear a lot as you go through the class. Not always referring to amines, but just in molecules in general. And it'll be kind of this concept of how many bonds are currently attached to it. So let's take a look at some other functional groups. You can really kind of classify those all as amines. I'm going to draw an H2 with a parentheses of an R2. And that just means that these could be bonds to hydrogen or they could be bonds to other carbons. Okay, so a completely different functional group is if you make a triple bond to a nitrogen. Because nitrogen can make 3 bonds, you can get one of these triple bonds. This is referred to as a nitrile. Or I believe cyano is what's written. Yeah, he's kind of got both of them there. So he wrote cyano in parentheses nitrile. There is an amide, which is kind of like a carboxylic acid. Amid can have a couple of different forms to it. Yeah, I'm picking up a 1-800 number. Okay. So these could also be similar to the amine, where you can have a primary and secondary amide. You could have something that looked like this. This is also still an amide. So, and I'm just gonna do one more for today, which is a nitro group. Box it off here. And that's gonna be, actually I'm gonna skip that one because that one starts dealing with 4 bonds to nitrogen. So you guys will get that into that a little bit more at the end of your class. So I'm gonna give you guys kind of one last big molecule to try and label, and then we'll probably call it there for today, unless you guys have more questions. So let me see. I'm gonna kind of take this one out of. Okay, so I'm gonna give you guys a couple of arrows and then have you guys go through this. And I'll give you guys about, let's go 5 or 6 minutes on this one. And then we'll come back and talk through it together. All right. So, also just so you guys have a sense of it, on Wednesday, I will probably have a molecule like this that I'll draw up. I'll have you guys turn on your cameras, have you label which functional groups you think it is, and then submit it to Canvas, and that'll be the quiz. So if you guys are wondering what your quiz might look like, this is a pretty good sense, seeing this is what we covered this time. So it's usually on what we covered in the previous recitation. I'll give you some extra time in this, especially for the first one, seeing as we have to figure out uploading and things like that. Okay, so for this one here, what is number 1?
Carboxylic acid.
Okay, carboxylic acid. We have both the double bond oxygen and the OH here, so that's going to be a carboxylic acid. Number 2.
Ester.
Yep. We have a very similar setup, but in this case, another bond to a carbon here instead of that bond to a hydrogen. Where's number 3? Number 3.
Ketone.
Right, so no oxygen now. We have another carbon there, so this should be a ketone. I don't know what the colors. 4.
Ether.
Ether.
Right, ether. 2 bonds to carbons. 5.
Amine.
Yep, that is an amine. Technically, this one would be a tertiary one because there's 3 bonds to carbon to it, but amine is fine. 6.
Alkene.
Yep, we have a double bond, so that should be an alkene. 7.
Alcohol.
Alcohol.
8. Oh, man, I cannot draw alcohol for alcohol there. That's the wrong thing. 8.
Alkyl halide.
Alkyl halide.
And then 9.
Alkyne.
Yep, so we have our Y and E because it is a triple bond. Okay, I think that's all I got for you guys today. Hopefully this was helpful. I will post when my official office hours are, probably sometime today. If you guys have any more questions, feel free to stick around for a few minutes. If not, that's all I've got.
Just to double check, so the quizzes, will they be open or closed notes?
Closed.
Okay, thanks.
Yep, you're welcome.
And is the quiz just covering the functional groups that we went over today, or is any of the functional groups fair game?
Just what we covered in this recitation.
Awesome.
I had a question going back to the first one that we did. Sorry.
Sure.
It was triple bonded, the alkyne group. We said it had 0 hydrogens on it.
Yes.
Why is that?
Okay, so it's the same concept as we have right here. So I'm going to kind of break it into a little bit of a smaller guy. So because we have these 3 bonds here, and then another bond to a carbon on this side, we already have 4 bonds. If we're thinking about this, the carbon that's in this middle guy here, which I'm having a hard time drawing an arrow to, that already has 4 bonds to it. So it doesn't have space for another hydrogen.
Okay, perfect. I think I might have been looking at the wrong carbon for that
Yeah,
one.
one side of it I think had a hydrogen, the other side didn't. So I may have just been a little ambiguous.
Perfect. Thank you.
You're welcome. And Peter, did you have anything?
Oh, no, I was just staying on. My bad.
No, you're fine. I'll just drop out of the room then. Okay.